Hey, so in this video I want to do problem number 15 from chapter 19 in Reingold's book. Alright, and he just asked us, can we come up with some method for accomplishing this transformation right here? Alright, and he does mention that it should be possible to do in 2 steps. Alright, so that looks like it's going to be a challenge. Let's figure out, not so much, or let's not worry right away about how many steps we're taking. Let's just see if we can do it, period, and then see if it works out with 2 steps. Alright, and given that it's 2 steps, what makes it hard isn't knowing all the steps, it's just figuring out which ones to use. And it's just kind of like a puzzle. So for me, it wasn't obvious right away what to do. And so in this video, I just want to take the time to really show you how I'm thinking about it and how I'm able to figure it out, even when I don't know the answer right away. Okay, and hopefully it'll help you just like think through the problem-solving strategy. Okay, so right away, I just look at what's different, what have we changed. Alright, we've added on both of these 2 ethyl groups, okay? And it looks to me like they went on that carbon, alright, but maybe not. That's just the immediate difference that I see. Okay, so like maybe they just somehow get on there. Now, then the next thing I think is, if I want to form new carbon-carbon bonds, like these 2, how do I do that? I use a Grignard reaction, okay? And we should know that by now. As soon as you think carbon-carbon bond, then you think Grignard. Alright, so which Grignard reagent do we use? Well, we're adding an ethyl group, so I would say we use the ethyl Grignard. Okay, now let's look at this in a little more detail. If I use this reagent, that would go, be used with some kind of carbonyl, and like what we're used to so far is just, say, a ketone. Okay, and we know that after we do the workup, the final product here we should be able to see right away is the ketone is changed to an alcohol, and we've added on the new carbons. Alright, so that's one way, and we've just added one group, but we see we have 1, 2 of them. Okay, so can we do it again? Well, one way you might think would be, can you change the alcohol to a ketone and then repeat the process? But I don't like that idea, and that's for a couple reasons. First of all, I know ways to make an alcohol into a ketone, but this one is tertiary, so I can't just oxidize it to a ketone because that's got too many bonds on carbon. Okay, and also, even if I could, I'm thinking, well, we'd take one step to do this, then if we'd have to oxidize it, that would be a second step, and then a third step to add the second Grignard reagent. So it doesn't seem right. Alright, do we know a way, something else we can react the Grignard with instead, a different carbonyl? Okay, in this chapter, the new thing is we could use an ester. Alright, so if you have an ester, what happens? Well, let's kind of go through the mechanism just because we haven't practiced that. The first Grignard attacks the carbonyl just like before, and the electrons move up. And what do you get? You get an O minus, and then the new carbons added on. But instead of immediately protonating this in the workup, this just quickly leaves. It kicks out the alcohol part, and you've got a ketone now, which we know ketones react with Grignards, so if there's enough of the Grignard reagent around, it shouldn't be surprising that it's just going to happen again. And we've added on a second ethyl group, and this time we are stuck with the O minus, which we can then protonate in a workup step to get the alcohol. Okay, so that seems to be a pretty good way to add on these 2 different ethyl groups. Alright, onto some ester. And then, next thing I think is, do we have an ester? Well, yeah, we do. Right away, we're starting with an ester, okay? But, I don't know, it still seems a little funny because if we're doing this, we're adding on the ethyl groups right there, okay? But we were thinking it would be nice if we could just stick on that carbon, okay? But the fact is, there's no functional group here to react with. There isn't a ketone, so something is not going to work there. But It doesn't seem like it's going to work on this spot either, but let's just see what does it actually form if you add the Grignard and let it attack this carbon. Okay, so let's walk through this carefully. I'll get rid of all of what we just showed right here. Okay. Now, okay, sorry about that. So if we were to add the same Grignard, it's going to attack that spot, electrons move up. So we formed one extra ethyl group. Alright, electrons go back down and kick out the alcohol part of the ester. So now we have something that looks like this. Alright, right there. So we just added on these two carbons so far. So what next? Now it happens again, we know. So here's a second one. The electrons move up. And we've put on a second ethyl group. Okay, so that seems fine. Though, we've got these, that's good. But now we've taken apart the ring. So it almost looks like we're not getting anywhere. It looks less close to what we want than we did when we started. All right, but let's just keep moving. If we were to use this reaction, we'd have the workup step, and we'd add the acid, and both of these should get protonated. So we end up with 2 alcohols. And it's just a 1, 2, 3, 4, 5, 6, 7 carbon chain. So there's this group is there, and then on the third carbon in we have an alcohol, and we have this second ethyl group. Alright, so let's just look at where we are right now. We added on these ethyl groups, and we have this alcohol, which was this oxygen, and then we have that alcohol, which was this oxygen. So make sure you can go through these steps and follow where the oxygens are. Alright, so we've got the carbons on, but we've taken apart the ring. We don't have an ester anymore. We have 2 alcohols. So is there any way we can put it back together into an ester? Okay, well, how do you make esters? So I know that if I want to make an ester, I can use the Fischer esterification with the carboxylic acid and some alcohol, and then some catalytic acid, and then that just gives me this ester. Alright, so I need a carboxylic acid and an alcohol. Alright, but I've got an alcohol and another alcohol. So is there a way I can turn alcohols into carboxylic acids? And if so, can I do it to just one of them, right, and not the other one? Right, because I want an alcohol and a carboxylic acid, not 2 carboxylic acids and not 2 alcohols, one of each. Alright, so how do I make an alcohol into a carboxylic acid? I use some oxidizing reagent, so Na2Cr2O7 is what we use, H2SO4. Okay. Now, is that going to happen on both the alcohols? Are both of them going to be oxidized? Well, luckily, no, because this group, it already is on a carbon that's got three bonds, as well as the alcohol. So it can't be oxidized anymore. It can't even turn into a ketone, let alone the carboxylic acid. Only the primary alcohol will react. So that's nice because I can do the reaction. And what do I get? This one stays the same. Nothing happened there. And let me do it this way. 1, 2, 3, 4, 5. So we have the carboxylic acid now. Alright, are all the carbons right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, looks good. So that's nice. I made a carboxylic acid with an alcohol on the other end, and then maybe I can make the ester. Okay, now I forgot to add the H2SO4. Alright, so how do I change the carboxylic acid and alcohol into the ester? Well, that was this reaction right here. Alright, I just have to add some catalytic acid. Okay, so if I do this, all that's going to happen is the alcohol part forms the bond where the carboxylic acid was. Okay, and I make an ester. Now that looks really weird because that's going to be, it's not going to look like that. The ring's weird, but let me rewrite it. So how many carbons are in the ring? 1, 2, 3, 4, 5. And then it's a 6-member ring because there's also the oxygen. All right, that it happens to be, doesn't just happen to be, it works, it makes what we want. All right, so that's great. We came up with a method. Now, was this just 2 steps? It doesn't look like it, but let's think about that. First step, we did the Grignard reaction, and I drew all these arrows, but really all of this happens in one sequence. So this is still reaction 1 at every point along the way, and up to the point for the workup step. So I'll be able to rewrite that in a condensed version with 1 step. And then it looks like I took another step to oxidize the alcohol and a third one to do the Fischer esterification. But if you notice, to do the oxidation, you've got to add the H2SO4. So whenever I add that acid in the reaction to make the carboxylic acid, it's actually going to go straight to the ester because this H2SO4 is just the same thing as the H plus that I would add later. So really, this is just 1 step, and I skip this guy altogether. It's just going to go from right here to right here. Okay. So let me rewrite everything now nicely and just summarize. First step, we do the Grignard, and we make sure there's excess of it. So that's step 1 with the workup. And we saw that that makes the dialcohol, where I've added on the 2 ethyl groups. Okay, then I do the oxidation and with the H2SO4, and we saw it made, I'm putting in brackets to remind us that this is just an intermediate. So it's going to make the carboxylic acid. But right away, it's just going to go straight to the ester. Okay, so it's really just 1 step, 2 steps. All right, so that's all it is for this problem. It's really, all this problem shows is don't get stuck into thinking, oh, I've got to add them all into this spot right here. All right, just because it looks like that. Just think about what has to happen. I've got to do the Grignard reaction. It's got to happen on an ester so that it will happen twice. We've got an ester. Let's just do an experiment. Let's see what it forms whenever I react with this ester, and then see if I can work from there to make what I want. And it ended up working nicely. All right, so I hope that helps a lot.